Hello, Algebra 2 and other data-interested students. I am here today to show you a little bit about how to use Google Sheets to look at the data that we collected last week so that we can consider what it means to be normally distributed or like a bell curve or like a Gaussian. Particularly in this unit, we're looking at what are called measures of central tendency, which is that if you collect more and more data, it's going to tend to be grouped together in the center, and also measures of what's called deviation, or how far it spreads out around that center. So let's see a real quick look over here at what it means to be a bell curve. So this is just an image from data science. So a bell curve is called that because it does look like a bell. Its proper name is a normal distribution, or sometimes the function, there's actually a math equation that models this, and it's called a Gaussian. If anybody's super interested, you can look up what a Gaussian function is. What you see here is actually marked out. One of the tools that makes using normal probability distributions useful is what's called the empirical rule, the 68, 95, 99.7 rule. And that actually tells us that a little more than 68% tends to be clumped right here in the center, which is why it's called central tendency. And then the next almost, you add another 14 and 14, 20 and 27. So 27 plus 68 gets us to 95. So about 95% of all data collected in a normal distribution is not more than 2 standard deviations from the center or the mean. We're going to get into that a lot in another day, but today what we are going to do is look at the data we collected and just explore it. So it's kind of a dual fold class day here. We're going to both look at how to use Google Sheets and how to visualize data, and it's actually more than dual. I'd say there's actually a third purpose, and that's just explore the relationships that data has amongst itself. So I went ahead and took all the data we collected. We had 31 responses so far. And I created, if you look down here at the bottom, 4 different tabs or sheets. So the first one is just so we can look cleanly at height. Next one's eye color. Next one's birth month. And the last one's favorite color. And you could do this all in one sheet, but I just think it's easier to look at in general. All right, so I want to show you some things about Google Sheets. The first one is if we want to see if it's normally distributed, I'm going to collect all this data, and then I'm going to open up a histogram. So you do Insert, Chart, and what pops up over here is, first of all, it gives you the chart it recommends. So it gave us a scatter chart. We have height going up on this y-axis. And so the x-axis is just every data entry. So it's kind of interesting because right away you can see that really almost everybody is grouped right here, between about 50 inches and a little higher, which makes sense. So the first thing I'm going to notice about this data is, wow, somebody said they were really short. That's actually pretty short too. I'm not even sure about this one. And this means somebody said they were 160 inches tall. So one of the things I'll ask you to do is figure out how many feet and inches that is, because that doesn't really make sense. So what that's telling me almost right away is we have a couple outliers that might just be incorrect data. Since we're collecting height, we actually can reasonably say the height outside of 2 bounds is not good data. Like there's really no way that anybody at Mill Springs is 20 inches tall. I think we would notice that. And likewise, there's really no way anybody's 160 inches tall. But I don't actually like the scatter chart that much, even though it told us a lot. And so I'm going to want you to explore different kinds of charts. One of the other suggested ones is a histogram, and that is the one that you want to use if you're trying to find out if it's normally distributed. This time it suggested it, but just in case you're ever in a situation where it doesn't, you can find the histogram down here. All right, so there's our histogram, which, in a way, I could kind of already see that follows a bit of a normal distribution. It's not perfect, but kind of does. You can customize your charts, make them a little better in general. We're on a histogram here. So right now, the buckets, or how big the spread is between different chunks in a histogram, is automatic. Let's say we change that to every 1. So that basically means every inch is going to be a different bucket. And then you can see, yeah, these down here, even the 41, I would question. For a lot of times, we really only have one person saying they're a certain number of inches. It's like we have a couple times 2 people said they were the same. Here we have 3 people saying they were the same. And here we have 6 people saying they were the same. So this is probably a pretty common height for 9th, 10th, and 11th graders, we would hope. But actually, I think 1 inch is too small of a bin. 2 inches is still really, I'd say, too small of a bin. Actually didn't even change, I think. We still have people saying 2 or up to 8. So I guess I did regroup it a little bit. 5 is going to regroup it even more. And 5 actually is the one where I can definitely see outliers. I don't know if this is an outlier. It might not be. I'm going to ask you to think about and make a good argument for what's an outlier and what's not. If I go to 10, it's probably not going to be good. Yeah, that doesn't tell me much. So I actually liked auto almost best. All right, so I'm going to show you now. What I'd like to do is actually look at these numbers in order. And I've already done this on this sheet, but I'll show you anyway. So the first thing you have to do is view and freeze and 1 row. And then you go click on the header row. And that just freezes, or in other words, keeps all this information together. And then you can choose whichever column you want to sort by. If I want to sort by grades, I just click on any cell. And then data. I want to sort this sheet by column E. I'm going to check, did leave column E, from lowest to largest. All right. Oh, interestingly, it's taking this as text, not numbers. And so that's why 9th is at the bottom. But it did sort it by grades. So, I don't know if that's interesting or not. You can actually sort by 2 things also. But I really want to sort by height. So let's try that again. Data. I want to sort by column F. Shortest to tallest. All right, so that 58 is probably valid. I don't think the 40 is, but I'm going to challenge you to give me an argument for why these are outliers. I'm just going to collect the ones that I don't think are outliers. And let me get rid of that. I'm going to do, insert chart. And our scatter chart looks nice and straight. I think I'd like to do a histogram. All right, and this is looking pretty good to me as a normal distribution. I would say it's what we call skewed to the right because it's kind of weighing a little bit to the right. And that's maybe reasonable too, because I would say we have an age distribution here also. And so it might be kind of interesting to look at a comparison of where these heights are by grade. But I'm going to leave that to you to experiment with. All right, so let's say I'm going to figure out what the mean and standard deviation are. So I'm going to label those because I tend to totally forget. So if I want the mean, I'm going to say I want to insert. This time not a chart, but a function. And mean and average are the same, so let's insert an average. I'm going to skip my outliers again and just grab the ones I think are good data. All right, and so that tells us that the average or mean of height collected is 67 inches. So that's 5'7". That feels about right. It seems reasonable. It's always good to look at your data and say, is that a reasonable answer that I got? And then let's insert a standard deviation. So insert function. It's a statistical one. And we want, you'll see there are a lot of standard deviations, and we'll talk a little bit about some of the others, but we want standard deviation. I'm going to collect that data again and see what we got. All right, so about 4.4. So with a little more than 4 inches, people are somewhere between 5'3" and 6'1". So that seems pretty reasonable for this population. All right. A couple other things I'm going to show you before I go on and challenge you to, in breakout groups, look through this data and answer some questions. If we go to eye color and select them all, as you know, I could sort them. Might be interesting to look at eye color by grade, or maybe not. That's actually a good question. Do you think it'd be interesting to look at eye color by grade or not? Let's look at all the color and let's insert a chart. And it chose a histogram, which I don't think is a great choice. So let's try. Let's look at our other suggested charts. I think a pie chart is probably good. All right, so our pie chart tells us that a little more than around 30% of the population's brown, about 30% is blue, and then smaller percentages are green or hazel. And I wonder how well that matches the general population and why it might or might not match. So that's a question I'll ask you. Birth month. So they're all selected already. Select them all, and I'm going to insert a chart. So a pie chart here is actually, you might notice it's already staying on the same chart that we did previously. And so I think a pie chart's not the easiest way to look at this. And so let's look at this by count, by histogram or count. So this is just a column chart. And so we can see that our highest birth months here in this data population are February and January. And I wonder what they are for the general population. All right, looks like I've already frozen this. And so I think I'd actually like to go here and sort this. So let's sort. Oops, and I actually created these respondent numbers by having it add one to the next row, which was not a smart thing to do. So I'll fix this before I give it to you. But so this sorted it alphabetically, which is actually not that great. I was trying to get one where it went from January to December. So I'm going to challenge you to figure that out. But yeah, that doesn't really show me any more than the other way. However, so I think I'll Control-Z that back so I can fix the respondent numbers before I hand this out to you. And then this is favorite color. So let's see what chart we get for favorite color. And so this gave us a pie chart. Its other suggested charts are the count. Maybe count that direction's kind of easy. Blue and red were by far the favorite colors. Nothing had only one, but several of them had just 2 votes. And I used the colors in the rainbow, Roy, G, Biv. So that's red, orange, yellow, green, blue, indigo, and violet. So the colors in the spectrum. Look at it either vertically or horizontally. I think it might be interesting to look at it by grade and which color they like. And I'd already sorted this data because honestly, I went through this entire thing and didn't have the record button pushed. So this is my second time through. I will have this all unsorted for you. So in conclusion, the things that I showed you how to do were sort data to order it, and you can order it by different columns, how to insert charts and look at them, and then reminded you how to figure out things like mean and standard deviation. And so I hope this was helpful, and I hope that you enjoy doing some exploring in small groups when we have class. And that's it. So this is Dr. M signing off. Keep calm, be happy, enjoy your day, and do some math.